In this video, we're going to discuss how to calculate the coefficient of variation, which is often referred to as CV. Okay, so for a sample, let me go and write this. So for a sample, the way that we calculate the coefficient of variation is we take the sample standard deviation, divide that by the sample mean. Oftentimes this is given as a percentage, to go ahead and multiply that by 100%. Right. So the coefficient of variation, what it is it's describing the standard deviation relative to the mean. Okay. For a population, if you have all the data in the entire population, then you can calculate the coefficient of variation for a population. It'd be sigma. Remember, sigma is population standard deviation divided by mu. Mu was the population mean, and then you'd multiply that by 100%. Right. So this coefficient of variation, reason why we use it is to compare variation between different data sets. Right. When the unit is different, basically the unit cancels when you do this, this division. So this is a unitless measure of variation. Okay, so that is very helpful when you're trying to compare variation between data sets. All right, so let's go ahead and calculate the coefficient of variation for this data set here. We'll calculate actually for both these data sets. This first data set, this is the number of phone calls per day. And we've been using this data in previous videos, so we actually know what the standard deviation is and what the sample mean is from previous videos. Okay, this data down here is this new data, so we're gonna have to calculate the standard deviation and the sample mean again. But this data, this is the age of like a clothing store customers. Okay, so 5 randomly selected customers. All right, so in a previous video, we found that the standard deviation for the number of phone calls per day of this random sample of 10 people, we found that S was 2.26. All right, and we also found that X bar is 4. So to calculate the coefficient of variation, we'll take 2.26 divided by 4, and then multiply that by 100%. So we can go ahead and pull out our calculator for this. Let's go ahead and clear it out. All right, so 2.26 divided by 4 times 100. All right, so 56.5. So let me go ahead and write that, 56.5. 56.5%. All right, so the standard deviation relative to the mean is 56.5%. So now let's go ahead and calculate the coefficient of variation for this new data set here. So to do that, I'm going to need to calculate S and X bar first. All right, so X bar, sample mean, is the sum of the data divided by n, and the standard deviation is square root of the sum of the squared differences from the mean divided by n minus 1. Right. So first let's calculate X bar. So let's go ahead and sum up all this data. If you sum it up, you'll get 100. Okay, and the sample size is 5, so that means the sample mean is 20. So now let's calculate the standard deviation. Now to calculate the standard deviation, I like to make a table where the first column is the data, 20, 24, 29, 12, 15. Second column is the difference from the mean. And then the third column is the square difference from the mean. Okay, so 20 minus 20 is 20, right? The mean is 20. So 24 minus 20 is 4. 29 minus 20 is 9. 12 minus 20 is negative 8. 15 minus 20 is negative 5. Okay, so now let's square each of those numbers. 0 squared is 0, 16, 81, 64, and 25. Okay, and then sum up this column. So the sum of x minus x bar squared. All right, so let's sum up that column. Let's go ahead and pull out a calculator for that. So 16 plus 81 plus 64 is 25. 186. So this equals 186. Okay, so then the standard deviation then is 186. That's the numerator, the sum of the squared differences from the mean. All right, divided by the sample size, which is 5 minus 1, and then the square root of that. Okay, so let's go and pull out our calculator and try this. So 5 minus 1 is 4. So 186 divided by 4, and then take the square root of that number. So 6.82. I'll go ahead and round up. So that 9 rounds that 1 to a 2. So 6.82. 6.82. Alright, so now I'm ready to calculate the coefficient of variation for this data. Be the sample standard deviation, right? XS divided by X bar times 100%. So 6.82 divided by X bar is 20 times 100%. Let's go and pull out our calculator one more time. 6.82 divided by 20 times 100%. So 34.1%. Right. So now if we're trying to compare the variability between the two data sets, one has a coefficient of variation of 34.1%, the other has a coefficient of variation of 56.5%. So clearly the number of phone calls made per day has more variability to it than the age of the store customers.